So in glycolysis, what you have going on is a single molecule of glucose is being essentially broken into two. So, here we have glucose, 6 carbons, 1, 2, 3, 4, 5, 6, there you go. And what you wind up with is essentially, it's broken in two here. All right, so 1, 2, 3, 4, 5, 6, just to simplify it a little bit. What's important is that these are 2 molecules of pyruvate. Okay, so 2 molecules of pyruvate are produced. But what's important is that along the way, 2 of these NADHs become reduced. So you form 2 NADH plus 2 protons of hydrogen. Okay. Now, there is a net gain, and it's important to note this is the net. Okay, and there's a net gain of 2 molecules of ATP also, so you get 2 molecules of ATP, all right? And that is glycolysis. That's essentially what we see with glycolysis. This illustration down below is just to simply illustrate how, for instance, ATP is formed, how, for instance, one of these phosphates is removed and attached to an adenosine diphosphate, ADP. And when it's attached, it forms ATP. So this is showing you, for instance, how this enzyme catalyzes that reaction to transfer a phosphate to adenosine diphosphate and form adenosine triphosphate in the process. So ATP is formed, just simply transferring that phosphate group in that process. Okay. So glycolysis has several steps, and we're going to break it into essentially the first 4 steps, steps 1 through 4, and then we'll take a look at the second 4 steps, 5 through 9, in that particular process. They call the first 4 steps energy investment. That's because energy is put in. You consume 2 ATP molecules. That's why the net, is 2 ATP at the end. Okay? Because you're using 2, you actually generate 4, but you use 2. You actually generate 4, use 2, so the net winds up being 2 in that particular case. The second step, 4 steps, 5 through 9, is what they call the energy payoff stage, or payoff phase, because you generate these 2 NADH molecules, you generate the 4 ATP molecules. Okay, here again, you consumed 2, produced 4, so, minus 2 plus 4 gives you a net of 2. Okay. I'm going to highlight this here. Consumed 2, produced 4, and so it gives you, a net gain of 2 ATP. All right, that's important. That's important to kind of pick up there. Okay. You also get pyruvate, which is important, which gets transported from the cytosol into the mitochondrion, so from outside to the inside of the mitochondrion. And it's important because that's where we're going to get most of our ATP through this oxidative phosphorylation. You get 2 molecules of pyruvate produced for each glucose. Okay, I'm going to highlight that too because that's important. 2 molecules of pyruvate for each glucose. Okay, so that's important to kind of note there. All right, so that's glycolysis, and I'm going to go through the steps here. And I don't want you to get too hung up on all this. What I think is most important is knowing the totals. So 2 pyruvate at the end, a net of 2 ATP in the process, so forth. I think that's more important than really grasping each one of these particular steps and knowing each one of these particular intermediates in the process. But to go through it here, the first thing, the investment, okay, remember this is the investment phase. So we have in this particular situation, all right, we're stripping off 2 of these phosphates. Here it comes right here, right? That phosphate is right there, okay? We do it again, right here, stripping off that phosphate. This time it's coming down here, okay? In the first step, we added to the 6th carbon, so we call it glucose 6-phosphate. Now, this step in between, you know, I'm not going to make a huge case out of this, but this is actually called an isomerization. Okay, because remember that what an isomer is. So an isomer, right, has the same molecular formula. So it has, you know, 1, 2, 3, 4, 5, 6 carbons. 1, 2, 3, 4, 5, 6 carbons. Same molecular formula, but you know it has, for instance, a different configuration. It has different. It's put together structurally differently. So you know, glucose and fructose are isomers. They're just arranged or built differently. So here you have an isomerization going on, going from glucose to fructose in that particular process. There again, I'm not going to make a huge federal case out of it. I'm just trying to explain what's happening here. In this 3rd step, we have another phosphorylation. We're adding that phosphate here. And so we wind up with a phosphate on the 1st carbon and the 6th. So the accurate term for it is fructose 1,6-bisphosphate. There again, I'm not so concerned that you know all these intermediates. Just pointing out that that's the correct name for this particular molecule. What's probably most important is this 4th step, because what happens is we have a split now. We're splitting this fructose 1,6-bisphosphate, and we wind up with 2 molecules of glyceraldehyde 3-phosphate in that process. Okay, we're not done yet. Remember, this is the first 4 steps. This is what we see as the energy consuming, because we've consumed now 1, 2 ATP. So this is the minus 2 ATP that we talked about earlier. All right. Now we've got the next 5 steps, actually, 5 through 9 in this process. We start with our glyceraldehyde 3-phosphate. Oops. Back up here. So I want it. We start with this glyceraldehyde 3-phosphate, okay? And remember, we've got 2 molecules, really important, 1 and 2. So we got two separate molecules here, okay? Each one is going to go through the same process. So to simplify this a little bit, what I'm going to do is I'm going to draw a line down here, okay? And I'm just going to simply say, you know, it happens twice. So this is just times 2, just same thing, but just happens twice in that process. So just not to confuse you, I just want you to focus for right now on the left-hand side. So we're just going to focus on the left-hand side here, okay? And we're not going to get so hung up on what's going on the right-hand side, because it's a mirror image. It's identical. Same thing is happening, just with the other molecule of glyceraldehyde 3-phosphate. First thing that we see a reduction. So NAD becomes reduced. What does that mean again? Well, it means that it actually gains 2 electrons. Okay, gains 2 electrons. Okay. We do see a phosphate added in here, and so, you know, we have another phosphorylation. Here's that other phosphate right there. Okay. Now, this is the energy, I guess you can say, producing portion, steps 5 through 9, because you have an ADP here. It's going to take one of those phosphates right there, okay, and it's going to produce ATP. Okay, so it adds. Let's just say adds to this ADP. The phosphate adds to the ADP and produces ATP in that process. The next step, we lose some water here. But eventually, in step 9, we have another generation of ATP. We strip away this phosphate, it adds to it, and we wind up with ATP here. Okay. Now remember, this is happening twice. Once for this molecule, and then once for this molecule. So we actually have 4. Right? We have 1, 2, 3, and 4 molecules of ATP. But I want to back up for just a second. Okay? Right? Here, right, we used 2. So we actually had a -2 ATP up here in the first 4 steps. That was the consuming energy. All right? So now we generate 4. Oops. Sorry. Now we generate 4 ATP. But we used 2 in the beginning. So our net is a +2 ATP. See that? But maybe more significant is that we wind up with 2, count them, 2 pyruvate. So we get 2 pyruvate in that process. Okay? That's glycolysis. That's glycolysis. Okay? Which in and of itself is an arduous process, but we have more. So let's take a look at how pyruvate is converted into, it's oxidized, and how it's converted into acetyl coenzyme A. Before I move on here, let me just summarize here a little bit. We have a net of 2 ATP. We have 2 pyruvate. This is a good thing to kind of, when you go in your notes, maybe to write in the margin, okay? But 2 ATP, 2 pyruvate, and we have 2 NADH plus H plus, okay? So maybe in the margin of your notes, you just write this to the side. But that's what we get from glycolysis. So this is all from glycolysis. Okay? All from glycolysis. All right. Now, the next step, the pyruvate enters into what we see as the mitochondria. So it's actually going to enter the mitochondria. And what we see is that one of the carboxyl groups is removed. Okay, here again, a huge deal here. But if we take one of these carbons, it's given off as CO2. Okay, so it's oxidized in that process. So it's actually given off as CO2 in that process. Now you have a 2-carbon compound, and it's oxidized, which means that we're stripping away 2 electrons, taking away 2 electrons again, and we're forming NADH. There's only 2 electrons, 1, 2. Okay, I'll try a different color here. 1, 2 electrons. Okay, so I've stripped those 2 electrons away like that, like so. And reduced in the process, reduced NADH, okay? And I've added, for good measure, I've added coenzyme A. And what I've formed is acetyl coenzyme A in the process. So coenzyme A joins with the 2-carbon group to form acetyl coenzyme A. Now, remember, there's 2 molecules going on here because, if I back up again, at the end of this process, right, we form 2 pyruvate, 1 and 2, at the end of glycolysis. So, at the end of this step here, what we wind up with are 2 acetyl groups. Okay, so let's start to add up here. In glycolysis, right, we had a net of 2 ATP. We had 2 pyruvate, right, and we had 2 NADH plus H2. Well, now we've swapped those out for 2 acetyl coenzyme A's here. Okay, so in this next step, which I'm just going to call pyruvate oxidation. In this next step here, we've swapped out the pyruvate for 2 acetyl coenzyme A, All right? And we've also generated two more NADH plus H plus. Okay? Here again, this might be good for the margin of your notes, just in the margin of your notes. So if we add this together, so far we've got 2 ATP. 2 plus 2 gives us 4 NADH plus H plus. Okay? So I'm just adding these to these right here. Okay? And that gives us 4 NADH plus. So that's kind of our running total is right now, just in the margin of your notes. All right. So now we start the Krebs cycle. A little bit of